Now IZZ2 is equal to IZZ what? 3. Okay. So the width is 95, or the coefficient is 95 over 53, multiplied by 0.5, 6 cubed divided by 12, plus, now this area over here already is including the coefficient already, right? So 285. Don't double do it, okay? 53 multiplied by 3.475 minus by 3, the whole thing squared. Okay. So 95 over 53 times 0.5 times 6 power 3 divided by 12 plus by 285 over 53 times by 3.475 minus 3 close bracket squared. I get 17.345. Okay, so 17.345. Okay, 17.345. If I make mistake, let me know. Okay, inches to power 4. I'll check again. 95 over 53 times 0.5 times 6 power 3 divided by 12 plus by 285 over 53 multiplied by 3.475 minus by 3 close bracket squared, and then 17.345. Correct. So the last one is IZZ4. Okay. So IZZ4 is 95 over 53 multiplied by 12, 0.5 cube divided by 12 plus by 570 over 53. Now it's 3.475 minus by 5.75, the whole thing squared. Okay, so 95 over 53 times 12 times 0.5 power 3 divided by 12 plus by 570 over 53 times by 3.475 minus by 5.75 close bracket squared is equal to 55.886. Is to power 4. Okay, so let me do it again. 95 over 53 times 12 times 0.5 power 3 divided by 12 plus by 570 over 53 times by bracket 3.475 minus 5.75 close bracket squared. So it's equal to 55.886. Good. So now we are going to calculate, okay, we are going to calculate IZZ total. So it's equal to 62.529, right, plus by twice of 17.345, okay, plus by 55.886. Okay, so 65.529 plus a 2 times 17.345 plus a 55.886. So it's equal to 156.105. Inches to power 4. Okay, so I checked it. 29 plus by 2 times 17.345 plus 55.886. Yep, it's correct. Okay. Now, why I encourage this way of doing a calculation, because every time at a certain milestone, you can check your numbers. Okay, you can check your number and you can check your numbers. Okay, so this is a good way of doing it. Not lump everything together. Okay, and then you calculate like I don't know where I gone wrong. Okay, don't do that. Okay. I know one student, I spoke to one student this week, and this student got a very good grades in this course. I think second highest, I think. And what the student did, I'm not going to embarrass this student. What the student did is, after doing this calculation, the student had a lot of time and program into Excel spreadsheet and check the answer. Okay. If you have time, do that. If you don't have time, don't do that. Okay. Now, someone put your hands up. You have a question. Hello? No. Okay. Sorry. If you had, I did
Professor,
not see. Yes.
Professor, are we still in symmetric bending?
Yes. Sandwich material.
Okay, so this is
Okay.
still symmetric.
Yes, it's still symmetric. Okay. But now it's sandwich material. Okay. Then after this, we're going to eccentric. Okay. Now, so what we realize is, okay, now what we realize is this. Okay. So we know where the we know where the I get tongue-tied. We know where the centroid is now. So I'm going to relative. Okay, I'm going to draw now. Okay, I'm going to draw our figure now. Okay. Okay, so we have. You know what? Yeah, I think I can still draw here. Yeah, why not? So I'm going to sketch our figure down here. So 6 and 12 to 13 in fact. 2, 4, 6, 8, 10, 12, 13. Okay. Right. So this is our our figure now. Right. Okay, so this is our aluminum. The rest is our Kevlar. And we know that the Y is 3.475. Okay. So we know that I'm going to just eyeball this. Okay. So this is 1, 2, 3, 3.4. So it's over here. Okay. So this line I've drawn is our what? Is our centroid. Okay. So so the question asks us to find the maximum stress, and we know what information we know also is we know that we are given a no, this is too far into the page. Okay, we know that we have a moment in Z, and this is equal to, we calculated that is equal to what? That is equal to 10800 pound inch. Right? So the question asks us to find the maximum stress. Okay, asks us, hey, can you guys or can we identify the maximum stress? Okay, so we know, right? So this is the analysis part. Okay, so what is the maximum stress? Do we need to? So this is above the centroid, and this is below the centroid, right? So based on this analysis, right? So we know that the distance from here to here is equal to 3.475. And then the distance from here to here is equal to what? Is equal to 2.525. Right? Now my question for you is, do we need to calculate the stresses, or which stresses do we need to calculate? Above or below? Anyone?
Above. Huh? Above.
Above. You're absolutely right. And why?
What is bigger?
What is bigger?
The Y.
Yes, because this distance is bigger. If you look at the formula, right? The formula is what? Stress X is equal to the N, right? And then you will have mz over izz multiplied by what? Y. So moment, so at the top, at the bottom, so for this case, if you, so it's like our 4 rules in what? In our shear force, right? Somebody, oh shoot, or in our shear stress, right? Somebody, oh, don't remind me, right? So regardless of what point you're going to find, right? mz over izz, this is always a what? Anyone?
Constant.
Yeah. Why is the changing part? Yes or no? Right? Why is the changing part? As you can see now, Curtis, you're right, above, and it's bigger, biggery.
Sir,
Bigger Y. Yes.
Why do you multiply by n if your IZZ's already adjusted using n?
IZZ is just it's just a geometry function. N is based on its strength. Okay, Justin. Now we're calculating. Sorry, now we're calculating the stress. Yes or no? Right. So when we started, okay, the n down here that we used initially, right, is to calculate the second moment of area. That is a geometry aspect. Okay, we did not. I mean, it's also a function of its strength. Now to apply, okay, to apply the function or the stress, we have to incorporate n at the top. Okay, does that make sense? I mean, we can
Yeah.
start. Yeah, I mean, Sean, sorry, it's not just Sean. I can start deriving it, but it'll take me like 20 minutes to half an hour. I don't want to waste your time. Okay.
Yeah, that's fine.
Okay. I mean, if you want, you can read the textbook. Okay. Right. So from here, we know that we have to calculate for aluminum. We have to calculate this distance, right? So basically, where we're calculating, okay, if I'm going to pick a point, we're going to calculate a point over here for aluminum. And we're going to calculate a point over here for our Kevlar. Okay. So I'm just going to squeeze everything into this page. Okay. So maximum. So we know that it's going to be what? Based on this, we have compression. And we have tensile. Okay. We have compression. So based on compression, or not based on, so we're going to find the maximum stress for aluminum, right? So stress X is equal to, our coefficient is equal to 1, right? And then moment is 10800. Y is, what did we say for Y? 3.475. And then divide by second moment of area is equal to 156.105. And it will be equal to minus. Why it will be equal to minus? Because it's in compression. Okay, so let me shift a bit. So this will be minus. So this will be equal to 10800 times by 3.475 divided by 156.105. So this will be equal to 1080, okay, times by 3.475 divided by 156.105. So it's 240, okay, 240. So minus 240.415, okay, pounds per square inch. Okay, so now we're going to calculate for Kevlar. Okay, it's also going to be compression. So now we just need to put in the minus sign, 95 over 53, 10800. Okay, and this is still the same, 3.475. Divide by second moment of area, which is equal to 156.105. Okay, so this will be equal to 95 over 53 times 10800 times 3.475 divided by 156.105. So this is equal to minus 431 or minus 430.933 psi. Okay, let me do it again. .933. There you go. Okay, so these are your answers. Okay, so how do you all find sandwich material? Anyone? Minus is the compression. You're absolutely right. So how you all find this topic? Anyone? Is it easy to understand, or you all have any other question? Anyone, please. It's not too bad, right? You know why? Do you know why you find it easy? That's my question for you. Do you know why you find it easy? Anyone? It makes sense.